Hello, everybody. Oh my God. So many people. I love it. Hi, and welcome to another Notorious Demo Day powered by Le Wagon. We are celebrating tonight batch 606, the full-time data science batch from Berlin. We have 36 amazing students who 10 weeks ago were strangers to one another, strangers to the data science curriculum. And today they are friends, they are colleagues, and they're becoming data scientists. Well done, everybody. Congrats. Congrats, congrats, congrats. I'm Andrea. I am the Events and Community Manager of Le Wagon Berlin, and I'm absolutely honored to be the one hosting tonight's event. I would like to start by thanking our amazing teaching team, all our teachers, batch managers, teaching assistants who gave everything, their passion and their time for our students. Without you guys, we wouldn't be here today. Our students wouldn't be here today. So a big, big, big round of applause to each and every one of you. Thank you to all our teaching team. Thank you to our staff members who are super kind and amazing and always ready for a challenge. I think our students know this very well. We are really happy to have an amazing team. And last but not least, thank you to these amazing people who are preparing some amazing projects for you tonight. So friends and families that are joining tonight, welcome to you too. Grab a fresh drink, make yourselves comfortable and get ready for some very beautiful projects. Now, before I'm handing the microphone to Annie, our campus manager, who will introduce you a little bit in what Le Wagon means and will give you an overview of the structure of the data science bootcamp so that you can understand better what these people learned in the last 10 weeks. I would like to encourage you to keep your cameras on. We don't have a proper audience with applauses and so on, so it would be nice to at least see some big smiles and some happy faces. Don't be shy and feel free to use the chat room. Feel free to cheer our students, to let us know what you think about their projects. So engage, please. We are more than happy to see some virtual socializing. And please keep your microphones off throughout the whole event so that we can have a very, very smooth presentation. I'm super happy to see you all. You have all beautiful backgrounds, by the way. And I want to thank you all again for being an amazing batch and to wish you good luck tonight. And to everybody else, enjoy. You will be amazed by our projects tonight. I'm handing the microphone to Annie now, who will tell us a bit more about Le Wagon. Hi, Annie.
Thanks so much for the very, very nice welcome, the kind words. For those who don't know me, indeed, I'm Annie, City Manager of Le Wagon in Berlin. And before we start, I just also want to thank our amazing teachers, our amazing TAs, the whole team. You've created an amazing last 9 weeks. I think that the people here kind of agree that we have made an amazing atmosphere, an amazing bunch of people that are going to show off tonight with their skills. So before we get going with the 9 amazing products, I would love to let you know a little bit more about Le Wagon and what we stand for. And let me see if you can see my display. I expect so. Can I get a thumbs up? Okay, perfect. So I think for most of us, it's very important to have that we know that we have one of these questions, right? It's very frustrating when you have an amazing idea, you want to build your own startup, but you honestly don't have a clue how to write these models that you need for it. Or you're working with data and with engineering team, but they're speaking in ancient Greek to you, you don't have a clue how to challenge them, and yeah, what are they actually doing? Or you've been always dreaming about a job into tech, into digital careers, but you don't know how to change that. So basically, you're like this. And that is where Le Wagon comes in, right? We bring technical skills to creative people like you. We'll make sure that we teach you how to code so you can build your digital product. You can land your dream job. You can reinvent yourself, basically, with a whole new career. So how do we do that? We have 2 different bootcamps at Le Wagon. The first one is the Web Development Bootcamp, where we teach students how to learn how to code. Within 9 weeks, they'll transform from somebody who doesn't have any coding skills into a full stack developer, and they can make a completely functioning web app. Or of course, a data science bootcamp where we are right now. And that is where we teach the fundamentals of Python, data analysis, machine learning, and all the tools you need basically to deep dive in the miracle world of deep learning. So we do that with a bootcamp of 9 weeks. This bootcamp is, I have to say, quite intense. And I think most of the students here agree as well that 360 hours might be a little bit of an understatement. But in terms of what we cover, we actually teach a lot. So we teach Python for data science. We cover SQL with databases, statistics. We touch upon machine learning, neural networks. And afterwards, we touch upon all different options in deep learning. And this is all geared towards setting up a digital product that can be used by real life users. In a bit, you'll see what kind of products are examples of this bootcamp. So we also realized that not everybody has the luxury that they can take 9 weeks off of their study or from their job. So we also have a part-time bootcamp where we cover the exact same, but over 24 weeks. And I have to say, we have gotten pretty good at it. We're the #1 ranked bootcamp in the startup part of Europe here in Berlin. And I have to say, we're pretty proud. So what are our alumni doing afterwards, right? They get hired as data engineers, data analysts, data consultants, and they also start their own startups. The businesses that are hiring our alumni are actually pretty cool startups here in Berlin as well. Think about Babbel, Contentful, BCG, Digital Ventures, or Adjust. Or, of course, also alumni start their own startups. There's over 100 startups already founded by our alumni, with over $100 million already raised by these startups. So who are our alumni? Think about Danny. When he came to us, he was working as a design thinker and coach, and that's not necessarily what he wanted. So he did the bootcamp and now is working as a data analytics lead at Paul Kemper. Or take Francois. He has been working first in sales. He came to Berlin to do the web development bootcamp. He started working as a product manager, and then he got in contact with a lot of data. He found his passion in data and then started working, did our data science bootcamp in Paris, and now is working as a data engineer at Papernest. Or take Brigitte, who has been going to the business school, then started working as a trading intern. She realized she wanted to gain more skills and now is working as innovation and digitalization data consultant at Berenberg. There's multiple ways how you can finance this transition into a new career. One of them is, of course, self-funding. The other options are financing by the German state, where you can get a Bildungsgutschein, which is a voucher for unemployed people for further education. This voucher will cover your entire course fee for you. Another option is the financing option with our income share agreement partner, Shansen. You can apply to them, they will pay your course fee completely upfront, and then afterwards, you'll pay them back in rates. What do you get for this? You get a lifelong access to all of the learning materials, of course. You get access to all of the cheat sheets, the videos, all of the lectures, and of course, all of the challenges, which also gets updated every time a new challenge comes out. And then you get access to our global network of more than 10,000 people. We have over 10,000 people across 43 cities worldwide. It's an amazing active network where you can always ask for help, where you can always ask for job openings, where people are very, very happy to help each other. It truly is an amazing community for life. If you're interested, our upcoming bootcamps are starting pretty soon, so please reach out to us whenever you're interested in this. And by now, I would love to give the word to Ben. He is one of our data scientists and lead teachers. He has been chasing our students for the last 9 weeks. And please give Ben a warm welcome.
Thank you so much, Annie. Hello, everyone. Yes, I'd like to hear some applause. Please open your mics. So welcome again, everybody, to the demo day of Batch 606. We said it a few times, but I'll say it again. This demo is actually quite special for me because it's the first time that I MC for it. Usually it's my partner Zuza who does it, and I can relax throughout the day and not worry about anything, but this time she forced me to do it. So to all the presenters of tonight, we're all in the same boat. I'm as nervous as you are, and we'll get through it together. So to the audience tonight, you're going to see 9 incredible products that are put together in only 2 weeks of work. And at the end of 7 weeks of even more work. So it's been a lot of work for all of these students. But you're about to see by the quality of the products that it was really all worth it. We're going to go from sports to politics to law, medicine, finance. We're also going to go through image recognition, text analysis, music generation, and much more. It's going to be full of surprises. So let's kick off the evening with our first group of the night, which is working in the field of sustainability. So I actually recently looked into installing solar panels on my rooftop. It's more and more common. And I began to search for the cost of installment, but also the energy that they would generate if they installed them, and how much I would save in the long run in terms of money. And then I quickly realized that the process of doing that and those estimations is long, right? You need to get an expert, contact the expert, have him come over to your house, measure your roof surface, etc. Very long process. Now imagine if you had an app that could generate all of these estimations for you. This is exactly what the first team of the night are creating, an app to do just that, and they're working with satellite images to do these estimations. Please give it up for Solar Vision.
Woo! Hi, everyone. As Ben said, we are the Solar Vision team. We are super excited to show you our final product. I'm Narciso Hernandez, and I will show you our product, and we'll tell you a bit about how it works and what it is. Also, I'm here with Naomi. So let me first start by saying 2 very shocking facts. So the first one is that actually, I don't know if you knew, but 1 hour, just 1 hour of sunlight is more than enough to actually feed the whole world's energy needs for 1 year. So 1 hour equals 1 year. That's crazy, right? But then another fact, which is actually, I would say a bit sad, is that actually 90% of all German households, they actually don't have solar panels installed. So that's a bit sad because there's so much potential just wasted, right? There's this huge potential and all this energy is just being lost there. So there's many reasons why it happens, but one big reason is because people just don't know, right? People just maybe they don't know how much will it cost to deploy, for example, solar panels, how much energy they can generate, and that's where Solar Vision enters. So let me show you our product without further ado. So here's this version of Solar Vision. I'm super proud of it. And let's begin by giving just a very simple example. So let's say I'm a user, and so before that, let's say the main purpose of this product is to actually make transparent the information regarding the solar potential of a given geographical area, even if it's a house or a bigger area. So for example, let's say I'm a user and I want to upload a file of a rooftop, right? So for example, I upload this one. We can clearly see that this image has a rooftop, and I want to show you what our system is doing. So I upload it, and then I do this algorithm. Basically, I'm letting my computer just think and do the heavy calculation. So meanwhile, I don't know, I want to ask you actually, what did you think it was going to predict? So as you can see, it's predicting 2 things. So one thing is that there actually are solar panels here, as you can see in the image, but also another thing, which is actually very shocking, and we're very proud of this. So it's showing the estimated area of these solar panels. I think that's great. We're doing this through something called image segmentation. Now let me show you another example. For example, let's say we want to go for a rooftop that is empty. As you can see here, this is empty. So let's see what our system does. So look, there are no solar panels whatsoever. I mean, as you can see with your eyes, there's nothing here. Now the question is, can we take this to the next level? And the answer is yes. So for example, let me search an address. So for example, I will search my dear friend's address. So this one, let's search. And what this system is doing is that it's actually detecting automatically, well, this address, then it will retrieve some satellite footage you will see here, and it's super amazing. And while it's doing this, Naomi will explain to you a bit about actually how everything is working under the hood.
So what is happening behind the scenes? The user on the platform sees a very nice interface, which we built with Streamlit, is hosted on Heroku. The user, as you can see, can either upload a picture or search for an address. We retrieve the satellite picture, cut it, then the picture is sent to the backend. In the backend, we have a package running on Docker container, which is hosted on the Google Cloud platform. On the cloud, we also have our data stored and do all sorts of calculations. So there is where the magic is happening. Then for the model, we have a TensorFlow convolutional neural network, which is actually the most popular deep learning tool for image recognition. Then we also trained our model on the cloud because our local computer is not strong enough to do so. Then we use the trained model to do the detection of the solar panel and calculate the area. The output is then sent back to the user and displayed there.
Great, thanks a lot, Naomi. Now let's go back to our system and let's see actually what happens. So let's go back again. So here, I want to first ask you, and please put in the chat or just, I don't know, show your fingers. How many solar panels do you see in this image? So there are 9 images. So this is retrieving the satellite footage of the address we just searched. As you can see here, I mean, I don't know about you, but I just see actually two out of these 9 photos that have solar panels, right? This one and this one, right? So our model predicted actually this. It says 2 out of 9 images were seen. So basically we're giving eyes to our computer. Now, why don't we try Le Wagon, for example? Let's search for Le Wagon's address. So, for example, here, and let's search it. Let's retrieve the footage super fast. And I don't know, let's see how well actually is Le Wagon doing regarding helping the climate and the environment. So I don't know, do you see some solar panels here? So here's our beloved Le Wagon. Here's maybe someone's car that is coming late to office. I don't know, can you see something? At least I don't see something. Let's see what our model predicts. And while it's still running, Naomi will tell you about which further steps can be taken and where can we take this to even to the next level.
So going forward, at the moment, we're able to get a satellite picture, cut it, detect solar panels and the area of it. The next step is then to detect rooftops. It's just a baby step away from what we're doing now. And can you imagine what we can do with that? We can detect the rooftop and the potential where we can install solar panels for a whole city, for a whole country, for the whole world. And then also calculate the cost of installment of solar panels, the energy we can generate with these solar panels. So we can create a marketplace, we can help consumers, investors, all the installers of solar panels and also governments. I mean, come on, Germany, you can do better, right? So let's help the environment and save the world.
Exactly, thanks a lot, Naomi. So now let's see what happened in our model. What does our system predict? So 0, okay, so you know, Ben and Susa, you made us do lots of challenges throughout these weeks. Now you have a challenge to call the landlord of this building and just tell him to install some solar panels, please. Just kidding. Okay, now Naomi will talk just a bit more about our amazing team.
So yes, this is our fantastic team, our super brains. We have Jan and Wolfgang and also Narciso, who is the head of the project, and myself. But we also want to thank our project lead teacher, Hai. He pushed us really hard to get to the next step and even further. And we thank Susa and Ben and all the teacher and the teaching assistants who brought us through this very tough 9 weeks. Thank you very much.
Thank you, Hai. Thanks a lot, Hai.
Make some noise. Amazing. It's so impressive. And the thing is, I know that this is just the beginning and that you guys are going to keep pushing and improving it, making it better and more precise. And I can't wait to see it scale on a bigger level, like a national level. I think it's a really great tool. Next up, so as I told you, we're going to go through many different domains tonight. The next group, they're actually the finance experts of Batch 606. And they took on the extremely difficult task of predicting the rise and fall of stock prices. Now, as you can imagine, predicting stock prices is not easy, otherwise we would all be rich. And actually, from a data science and machine learning perspective, it's probably one of the most technical tasks Please give a warm welcome to my man Luis, his group, who will present to us their intelligent trading tool.
Hi, people. Thank you very much. So I'm Luis Perez, and I was working in the last 2 weeks with my amazing team with the stock prices prediction. So basically, we have an agenda. We identify a problem. We set a data set. We build some models over it, and we make some applications to develop. So basically, we are always listening in the movies or in series like Wall Street and the stocks prices and all this graph and all this stuff that you can make some money with them. But actually, it's quite complicated for us to follow all this trend, all these numbers, all these statistics. But luckily for us, we have computers that are better, way more better than us to make this mathematics, this prediction, this analysis. So we try to take this power that this computer have and try to make some predictions with it. So we take a data set from Kaggle. We split the data. We have a data set from the 70s until 2018. So we split the data. We reduce the time range from 2000 to 2018. And we select 10 stocks from the 500 biggest companies of the USA market. So we select 5 risky stocks and 5 stable stocks. So we select stocks like Apple, JP Morgan, NVIDIA, Telecom, just to analyze how they are performing across time. So we was working in 2 models. We work with a time series approach, which is a machine learning problem, and we work with a deep learning approach, which is a recurrent neural network algorithm. And we have better results with the long short-term memory algorithm. So we decide to move forward with this model for our product. So basically, what is a time series? We taking a long period of time, so we're taking a lot of data from the past, and we are analyzing this data to find patterns and identify trends that allow us to predict the future. And we are also was working with a recurrent neural network. This is also taking data from the past, but not like a big range of data, just taking a piece of the past and trying to predict the future. Like in our case, we select this and we was trying to take the 19 previous day and we want to predict the next days after this. So with this model, we made 2 applications. So basically we make a stock price prediction that, as I say, we take for example, we select a stock on a specific date, and we take the previous 19 values and we try to predict the next day value for this specific stock. And also this price will be an input to take for the other model that we developed that is called AI Trader. My partner Bruno here will explain much better what is doing the AI Trader.
Okay. So what is AI Trader? AI Trader actually takes the stock price prediction to another level. It takes the prediction that it does every day and the prediction to the next day and replicates it throughout an interval of time. So what does it do? It predicts the stock prices for, let's say, the 10 stocks that we have. And let's say 5 of them are going up and 5 of them are going down. So what we're going to do, sell those 5 stocks that are going down and then buy some more of the ones that are going up. So you actually do buy and sell, and then you earn some money and repeat that every day. So let's say you have a friend that is going to buy and hold those 10 stocks for like a year and does nothing at all. And then the other friend is actually going to use our AI Trader, buying and selling the stocks every day. Let me show you the website we created to do this. First, let me show you the stock price prediction for the next day. So we pick a stock here, and then we can choose a day to predict. So let's say June 16, and it gathers the 19 days prior to the date you want to predict. It shows on the line graph here. Then you have the real price, and then the prediction. So our model, the AI trader, you'll see the next, it's gonna actually buy this stock because it's going up, right? Then let me show you now the AI trader. So you have the 2 dates. You wanna check how the AI trader does during this time period, and then how much money you wanna invest. So let's say those 2 friends, one chose to buy and hold those 10 stocks, and the other one chose to do the AI trade. So the buy and hold friend would be happy with 17% return, while the other friend got a 127% return. He's like the happiest friend, right?
Yeah, thank you, Bruno, very much for the explanation. I should take advantage of the benefits of AI Trader and give it all my money to this bot for sure. So the amazing team that was working with us that for this past 2 weeks is Bruno, Tara, Sandra, and me, and Luis. Yeah, it was an amazing experience. I would also like to thank you to Ben, Susan, Nizar, and all the amazing teachers and TA that helped us during the past 2 weeks. And this was our project. I hope that you like it and make the money rain, please.
And as 50 Cent would say, get rich or die trying. So next up, I actually am a huge football fan, and we're going to go to football and sports now. So the next group is a special one for me. These guys, they've created a tool to predict the market value of football players based on their abilities. This group faced a lot of obstacles in the last 2 weeks, but they found solutions to every problem that came their way. I'm really super proud of what they're going to present to you tonight. Please make some noise for the football boys. Hey, woo, woo, woo.
Wow, thank you, Ben, for this amazing introduction. Yeah, and hello, everybody, and welcome to our football pitch. As Ben already mentioned, we're going to talk today about our nice app, which is a football player market value prediction. And let me start with a quote from Pep Guardiola. And he said, the most difficult thing in football is to score a goal. And if we talk about the market value, of course, right now, you may understand why the most valuable players out there are the Messis, the Ronaldos, and the Neymars. But there must be obviously more than just goals, like take it into account when it comes to the market value of a player. So this ad is for you. If you're a professional player, a player advisor, football manager, an investor, sponsor, a scout, or a club, or even just a fan, listen up, because we determine the market value of a football player and what it is specific. So how we did so, finally, we took a database of more than 4,000 players. And yeah, we checked out the last 3 seasons of football, and we just considered the 5 biggest leagues within Europe. We just split all the players within 3 positions. We're just coming with defenders, forwards, and strikers, and midfielders, sorry. And finally, we added another 19 characteristics to our database, which is, for example, passes, goals, but also assists, played minutes, etc. We will learn more in a minute. Let's explore a bit the database that we used. And just to give you a short visual introduction here, you see here the Premier League, which is the English one, is the most valuable one. And if we take a look about regarding the position, I told you the defenders, the midfielders, and forwarders. No surprise so far that the most valuable position is sitting under the forwards. There's much more to learn about the database, but I think it will be more interesting to go into the prediction. So let's start, because this is where the fun sits. So finally, this is our prediction platform, and it just needs a user input, which you can see here. There are 2 opportunities. One might be just to go here and you're going to enter a database. Let's do it. For example, we prepared something for you for Robin Gosens. Let's check it out. And you see it here, the data frame is changing. So we see there's a defender with the age of 26, and he's a left foot playing in the Serie A. Finally, we made a prediction categorization coming in 4 different categories, which is sub-average, so let's say market value between 0 and 5 million. We call the average in category 1, something between 5 and 50 million. The category 2 are the high performers, 15 to 30 million. And finally, the category 3, the world-class player. All the players, more than 90 millions there. So let's see what our app is going to predict for the values we added here for Big Bones. And it says he's a world-class player with a prediction of 45% rated to the category 3. So it might be a market value of over 30 millions. Let's check this out if it's true. Okay, there's fortunately a super trustable page, which is called transfermarkt.com. And if you have a look here, you can see Robin Gosens right now playing for in the Serie A, and he's a defender, and he's coming with 35 millions. So this looks all right. Yeah, so we learned already. Okay, fine. It works for our specific product we offer a specific player right now here, but better it is already, you can also play with it. So you can create, for example, let's say your own player, like call it Philip Ronaldo or whatever, or maybe you are a professional football player and you want to know what might be your market value, maybe in the future by changing the age, etc. So there might be some opportunities, and you see super interactive. So we start here for our example with a striker, a forward, and let's just give him some more goals in this specific example. And you're going to see by increasing the goals, all right, okay, he's turning immediately to an average player. So you see his market value increased. And this is, of course, like given an example. So if you would increase significantly, he would be a world class. And finally, something between, he would be a high performer. So it's super interactive. And then you can like figure it out for each position, what might be more valuable and what might change your future market value there at least. But how does it work? Let's have together a look under the hood. What is also quite interesting here is to see like how the entire process and workflow goes. Finally, there's a Python script behind it with some libraries for data cleaning and for some data visualization. Finally, we used the scikit-learn library, which provides us with some machine learning models. There was a database we obtained from a Kaggle challenge. And finally, we did the web scraping from transfermarkt.com, which comes with the market value. So this is where we got our targets from. The model finally we tried out several models, but it turned out that the support vector classification comes with the best feedback for our specific task. And so we continued with that one. But what is even more interesting is how it works for you. So you can also use this app on your mobile phone. So it's not only located on my computer, it's accessible from all over the world. And that's possible since we put like the data on our backend, hosted via Heroku, and the Streamlit is provided, the Streamlit functions providing us with the front end. So this brings the dots together. Yeah. So there's just one thing more to say to bring it home, and that's it, at least to take a look about it, like to our amazing dream team. So these are the guys who work with me together, which is Milav, of course, and Udoka, Konstantin, and Aytac. And I just can give you the recommendations since we're running out of time. I need to pass back to Ben. Just take the time, visit our app, and finally, also here are some fun facts for my members of my team. And what can we read here? With the age of 9, Konstantin attended an FTN by a Munich scout training. What would it have been like if we would have a chance, like with this nice, amazing app, to get there and finally, check out what might be his market value? And that's finally something that we would like to do in the future. So if you will give us like more time and more chance, this is something we would like to love with it. Specify the model for youth players and their predicted market value, extend it to more leagues and divisions. And of course, also the women's out there might be super interesting. So some prediction for female players as well. But that's it so far. So that's the future, and let's see what the future brings. So giving back here to Ben, and see you guys all in the future.
See you at the party. Make some noise. Amazing, boys. You guys did a great job, and this makes me so excited for the Euro, which starts tonight, by the way. Everybody behind Turkey tonight. Sorry for the Italians out there. Next up, we're jumping from sports to the medical field. The next group, they have decided to participate in the fight against the COVID pandemic with the tools that they learned during the bootcamp. They've put together a sophisticated 2-step model that can not only detect the presence of COVID in a patient, but also predict how urgent it is for the patient to be hospitalized. They're going to tell you all about how they did that. Please welcome to the stage Nina, Cyril, Eitan, and our superstar Ali.
Oh yeah. Woo!
Thank you, Ben, for the introduction, and welcome everyone to the presentation of our COVID-19 imaging diagnostic and prediction tool. As Ben already mentioned, this project was inspired by the challenges that the medical community has faced during the COVID-19 pandemic around the world. And with the rise of COVID-19, hospitals and radiology departments have been overwhelmed with an influx of patients presenting with COVID-19 symptoms. So to provide optimal care to these patients, it is critical to get a speedy and accurate diagnosis. But with hospitals working at capacity, prioritization of diagnostic resources and appropriate treatment cannot always be guaranteed. But let's have a look first at how COVID-19 and COVID pneumonia is actually diagnosed. So when a patient presents with the typical COVID-19 symptoms, such as cough or shortness of breath, the patient or the doctor orders first a blood test and then a CT scan. When we get a CT scan, so we usually would expect to get a 3D image of the lung, but actually a CT scanner provides us with a bunch of images, so usually between 100 and 400 images that are taken in the axial plane and from the top to the bottom of the lung. And these images we can then recreate to get a 3D image. But how can we use this to improve diagnosis and predict the course of disease? So we want to support with our tool doctors by using machine learning and deep learning. What we do is we feed the CT slices of a patient into a deep learning neural network, which then gives us a prediction and classifies whether a patient is COVID positive or negative. So how did we implement this, and how does our product diagnose and evaluate the disease risk? So as I mentioned before, we start off with our CT scans, which we then upload on our website and feed it into our deep learning model. For this model, we use the convolutional neural network, which is best suited to classify images. And we then obtain a diagnosis and know whether a patient is actually positive or negative. If the patient is positive, we also want to understand what their risk is, so their mortality risk. So for that, we use clinical features. So those include the age, for example, and different results that we get from a blood test from a patient. And we feed this into a machine learning model, in our case, a logistic regression. And we then get an evaluation of their mortality. So we know that the patient either has a low or a high risk to actually die from COVID. But let's have a look at what our product actually does and how it works. And I will hand over to Ali to guide you through the steps.
Thank you, Nina, for the wonderful explanation, actually. I'm very proud and very happy and excited to present our product. We've been working on it tirelessly for the last 2 weeks, and we came up with this at the end final result. So our product is basically has an easy interface, intuitive too. As you can see, it consists of 2 steps, but powered by a very sophisticated and powerful models that are excellent for image recognition. So as you can see, it's actually 2 steps. Step number 1 would be uploading your CT images. We can choose a random CT images from a patient and upload them to the model that would now try to analyze them and give us a prediction if a person have COVID-19 or doesn't. I would like to hint out at this point that this tool is made for medical staff and medical personnel who are always working hard and always under pressure, especially at time of crisis and time of pandemics. So we're hoping that this would reduce their workload and help them help their work environment and help the patients actually at the end. And if the patient would be negative for COVID, then we don't go further. But as we can see, our patient actually has infection, and the model tells us that he's positive, which leads us to step number 2. Step number 2 here is evaluating the mortality risk of the patient. here, instead of giving our CT images, we use actually we use information from the same patient, but those information are not the images, but the clinical features. What are clinical features? As Nina mentioned, there are, for example, age or blood work, including, for example, inflammatory markers and stuff like that. And this type will tell us if the person has low risk in mortality or a high risk. And this will lead us to know if this patient needs actually extra attention from doctors or not. As we can see here, on top of knowing that the patient is positive for COVID-19, we also know he has a high risk. Seeing this overall picture, knowing that this case is like this will give us we can now like prioritize our patients, we can prioritize our resources, especially at times like pandemics. But what impact does this have? Maybe Nina can tell us a little bit more about that. Back to you, Nina.
Thank you, Ali, for the demonstration. So yeah, what is the actual impact of our product on patients and the medical community? So we now saw that we can get a quick diagnosis of the COVID status of a patient, but also whether they have an increased risk of actually dying from the disease. So the impact is that we don't actually need a doctor to be present at the time. So we can feed in the images of a scan and get like a direct diagnosis. The other advantage that we have, we can use our tool from anywhere. Anyone can upload the images and at any time of the day. So we're hoping that with this product, we can free a bit of the physician's time so that he can actually take care of those who most need the treatment and thereby help or increase survival of the patients. This was our presentation. I would also like to thank the amazing team that has been working on this for the past 2 weeks. This is Eitan, Ali, and Cyril. And then also a big thanks to our 2 actual 5th and 6th team members, John and Chris. And then thanks to Ben for pointing me to the data set, Zuza for all your help, and all the other TAs and teachers that have been helping along the way. And we could have not done that without you. Thank you.
Thank you so much. I actually had forgotten that I pointed you to that data set. Thanks for reminding me. Next up, we keep switching it up. So next up is Juan and his group. And so when Juan first approached me with the idea to create a music generator from human emotions, I thought that it would just be too much of a challenge for 2 weeks. But he came back, he was persistent. He came back to me with a solid game plan, and he really convinced me to give the project the green light. These guys are going to show you just what can be done with deep learning. Please make some noise for our in-house musicians, Juan and his group.
Thank you, Ben. And can you see my screen and hear me?
Yes, we can.
Okay, thank you very much.
Sir.
And welcome. And I would like to introduce you our project, which combines music and data science. The purpose of this project is to explore and search for ideas for music composition. It's a journey of exploration. To give you a better idea of what it's all about, I would like to show you the application we were thinking about. In this case, a user could upload a picture, and the application is going to process this picture and find out which emotion is in this picture, and end up with a fine small piece of music. And also raise this question: can a machine be able to create music by itself? Just forget into details and how will be this possible. Simone is going to start explaining to you our project.
Thanks, Juan. So yes, let's have a look at what happens behind the scene of the application. And basically, when the user uploads a picture, it is fed to a so-called convolutional neural network, which is basically a model that applies various layers, each specialized in detecting specific features, making it very powerful and suitable at analyzing pictures. And so the task of that first step is to identify a face in a picture and extract an emotion. The second step is feeding this emotion to an encoder, which is an algorithm that translates that emotion to some nodes, and then finally feed that nodes to what's called a recurrent neural network, which basically adds an element of memory to hold this, making it able to analyze temporal sequences and therefore very efficient and powerful at looking at tasks such as language detection, language processing, and also music. So let's dive into the first step, face recognition and motion tagging. Basically, the first step that we do when we upload a picture is a face is detected, it's converted to grayscale and cut to a specific size to match the pictures that we use to train our model. So in the first, at the beginning, we trained our model with 35,000 pictures, which were tagged with 6 emotions. As you can see, angry, scared, happy, sad, surprised, and neutral. And at the lower part of the image, you see what the model basically does when it sees a picture. It recognizes the face, it focuses on a specific part of it, and then returns a probability of a specific emotion being detected. And we reached more or less an accuracy of 65%, something above it, which was pretty good if you compare it to a human being on average being able to recognize 75% of the emotion that is actually fed. So the next step is the encoder, where basically that emotion is translated into 7 nodes that correspond to a mode that the human ear is used to perceive as a happier or sadder music. And so, yeah, that's the next step. Juan, please get us through this.
Thank you very much, Simone. And yes, the third part of the project and also the last part is we're going to take those notes and start a melody. And then we're going to use, sorry, another model in order to continue based on this first melody to continue and end up with a piece of music. In this case, we are using an open source project, which the name is Magenta. And yeah, in order to answer the question I posed earlier, it is possible to create music for a machine by itself. I am very happy and proud to show you that we ended up with this nice application. And yeah, here actually the user can upload a picture. Here, I want to give you a small demonstration. And then let's see what happens. Takes a little moment. Yes, and now we can see that the first part of the project is performing well. The first model is just detecting the correct emotion. And I want to share with you how it looks like or sounds like this emotion. I wanted to point in here that actually this music was created on the fly. Every time that the user just upload a picture and run the process, is created a new music composition. And I think and I believe that this kind of tools can help artists and people just to expand their creativity and yeah, I wanted to thank a lot the team, my team, Georgios, Simon, Daniel, who were following me during these last 2 weeks, and they made just this project real. Also, I want to thank you, our personal TA, Nizar, who were there for us and helped us a lot, and as well the team managers and Susa and Ben, who were like there for us and supporting us, and also carrying us till the end of this nice experience. Thank you very much, and thank you for watching.
Amazing. Let's see if we can plug it into the speakers tonight. Moving on to the next group. So the next group, they developed a marketing tool to identify Twitch streamers who have an audience that best correspond to a product you might try to sell. If you don't know what Twitch is, don't worry about it. They're going to tell you all about it right now. Please welcome Starfish. Sorry about that. Big round of applause for Starfish, people.
Yeah, hi. Hello, people. Thank you, Ben, for the nice words. They totally nailed it. And let me introduce you to our idea. Yeah, we're the project Starfish, and our goal is to address a whole new market. But let me introduce you our idea by introducing you to Twitch. And maybe you have an idea, but to be sure we get the main facts, we know we use flashcards. Name 2 important main facts about Twitch. Okay, don't know. Okay, Twitch is a platform to broadcast video games, and there are 3.3 million unique users streaming themselves playing video games every month. And this fact, 3.3 million unique people streaming themselves, brings us very close to our idea of a starfish. But let me introduce your starfish maybe with an idea about the person himself. When we think about the starfish, the typical starfish loves playing video games. He's passionate about streaming himself and loves to grow a community. And what is very important, during a week, he's streaming 60 hours. When you compare on average, there are 250 people watching him this time. And another note here, 60 hours and 250 people, that's the main data of our project. So we learned a little bit more about one of our main characters. As you may maybe remember, in the beginning, I said we want to introduce a whole new market. Yeah, that's it. With our technology, we provide the right indicators to marketers to build confidence in the decision-making process. Think about the following idea. Maybe you own a product, for example, an energy drink. It tastes well, maybe good, and you decide to target some people, an audience, customers. There are many ways to do it. Even you could reach out to streamers by yourself, but until today, there's no way to build a confident group based on data. And to show you what I mean, let's jump out of the presentation to our dashboard. And what we can do here, I was talking about hours and followers, and we can select them here. So let's take the average viewers. Also, let's take the hours watched. And our main goal in this project was to scrape so many data. So we even have all the social media channels. So let's connect Twitter, for example, and let's have a look on the data frame here. And when I move this one here, I hope there are some changes. Oh, yes, there are. Lucky me. And I even can aggregate the data with an easy click on a button. And there's some changes in this graph. And okay, I can see here the hours watched by every streamer. And I can see all KeyShop is very far away from the others. So, okay, I like this guy. So yeah, let's just stay with him because I'm interested in selling my energy drink. And when I watch on hours watched and the average streamers, I get an idea how many people will watch my product. This is very important. So here I can watch like the main games he's playing. And even if I don't know much about games, Counter-Strike, yes, that's a big number. And when he's playing the main games, like the mainstream games, I can make sure my energy drink, my product is introduced to a wide audience. That's pretty nice. Yeah, let's move on. I said we also connected social media channels, and what is pretty cool, I even get an idea about the follower count. Okay, looks good, almost 40,000. What is pretty cool, I can look on the live streams. I mean, I get an idea, okay, what are the people talking about? But the coolest tool about our dashboard is the one here in the bottom. Think about the idea. I don't have so much money. Maybe I have an energy drink, but to address the whole world with this, nope. I just have money to enter the German market. And here I can have a look on the community base. And wow, okay, maybe the streamer I selected is a no, because no one of his community is based in Germany. So yeah, he's not the right one, but now I know this. And this is so unique about our idea. There's no way what is aggregating all the data from the internet so you can make a confident decision about your next moves with your business. And basically, that's it. That's the Starfish idea. And now let's switch back and I will hand over to my colleague, Simon, for some last words. Thank you.
Wow, this is going to save me so much time. Oh, sorry, I wasn't muted anymore. Thanks, Ludwig. Amazing presentation. It is such a cool product. Like our main idea was to make use of all the information that is out there online and just make it more digestible for marketing actors. And I think we did kind of like a really good job in presenting our first minimal viable product. So I'm really speechless how far we've gotten until like within 2 weeks. It's amazing. And I think like our team did such a great job by just like working and sticking to our game plan. And I'm really really proud. Here you can see them like Katarina, myself, Alessandro, and Ludwig. I think everyone brought some features to end up with this amazing product. Also, Sus, Ben, and obviously our PA Renan, who is not here today, unfortunately, but really thank you guys. Thanks to the whole LeVagon team. It was an amazing experience. I'm really tired, but I'm really looking forward to the party tonight. And don't forget to reach out to us on GitHub. Here you can see our nicknames. Yeah, obviously we're going to build upon our newly created GitHub profiles, but it's going to be amazing from now on. Like code. Thanks. Woo.
Guys, make some noise. Open the mics. I love it. Thanks. By the way, quick reminder, speaking of the party tonight, just a reminder that you need a negative test to be able to get in tonight. So if you don't have one yet, please make sure you get that before you head to the party. Next up, we're going to change again to another domain. We're actually going to jump into natural language processing. Natural language processing, it's also called NLP because natural language processing is just too long. NLP, it's the analysis of human speech, either via audio or text. And it is as hard as our language is complex, pretty much. The next group, they looked into the analysis and detection of political ideas in text. Please welcome Andreas, Barbara, Felipe, and Anton. Up, open the mics.
Hi, thank you, Ben, for the introduction. Opala. All right. So, welcome to the project presentation of our project, Terminator meets Frau Merkel, aka Bundesterminator. I'm Anton, and I will guide you through the first half of the presentation, and my teammate Barbara will host you for the second half. So, who are we actually? Thanks, Ben, actually for already introducing us. Well, it's us, and we had a lot of fun doing the project. But let's get back a bit. Terminator, what does this have to do? So our project is about politics, about humanity, and also about machines. And especially humanity and politics are a different topic because, well, it's us. We're humans. We're terrible. So what is the problem? What do you want to solve? Imagine you just want to know the political party affiliation of someone, but they just don't tell you. So what can you do? You can try guessing, but as you know, nobody can guess 100% accurate, and you can definitely make some mistakes. So just think about it. For example, we here in Germany, we understand German, we understand our politics, or mostly because we speak the language. But what about foreigners? They have troubles understanding it. Or what's with machines? The thing is, foreigners and machines, they just don't know our language. So we decided to help. And how did we do it? Well, our idea was that we want to try to predict the party affiliations based on a text, and we want to do this as precise as possible. So, and what did we actually do to achieve this? I mean, it's 2021. Of course, we made an app for that. So let me just show you that app very quick. This is our app. Here we can choose a machine learning model. And here we can type in a text, for example, let's type some polarizing. This is German for Nazis get the hell out of here. And let's see which party could have it's been aligned to. And it gives us the left-wing party in Germany. So this is already pretty nice. Let's try another one. Let's try this one. Let's try Gewerkschaften sind wichtig, which means unions are important. Which party could have said this? SPD, also quite obvious. So I don't know what you think, but to me, this is just magical. And how this whole magic works, this is something that Barbara will tell you. So thanks for attention, and I'll give it all to Barbara.
Yes, hi everybody. And thank you, Anton, for this great introduction to our project. And now I will give you a brief, hopefully not too technical overview of the magic behind this. Okay, how did we do it? We used natural language processing, which is a subfield of artificial intelligence, which focuses on the human language. As a data set, we used the well-documented speech transcripts of the Bundestag, which are publicly available on their website. And the goal was to classify text into one of our 6 classes, which represent the main political parties in the Bundestag. But, well, as most of you might know, and Anton explained that pretty well, computers are not so good in understanding text itself. They rather work with numbers, so the speeches had to be converted first. And this can be realized in different ways, and I will show you the 2 approaches that we explored. So in our first model, which is a basic classic machine learning application, we used a method called bag of words, which converts each word into a number, which then is counted, and which gives us the ability to find similarities in texts based on the frequency of words. This approach already gave us pretty decent results, but yeah, we wanted to try something more than just basic counting. So in our next approach, yeah, thank you. In our more advanced deep learning model, we used Word2Vec to convert our text. Word2Vec, that's a tiny little machine learning model itself, and it finds a representation for each word in a multidimensional space. And here, I mean really multidimensional. I guess you can all imagine like a 2D space with X and Y axis. 3 dimensions might also still be fine, but this guy here, he's handling up to 300 dimensions, which is just mind-blowing. Anyway, these vectors in space, they give us a great way to actually calculate similarities of different words based on their position. And well, with these now converted speeches, we trained our deep learning neural network, which we can then use to predict the correct party affiliation for a given text snippet. Yeah, and as you have seen earlier, we are quite satisfied with the results. It was working pretty good. But of course, there's always room for more. So for future development in our app, we could imagine to try to extend it to predict maybe party affiliations from Twitter posts. Here we'd have to retrain our machine learning model to adapt to possible differences in speech style in social media. And another thing that could be possible could be to represent the speeches in topic-related clusters, where we could then maybe identify different affiliation of a certain politician to a specific party, or maybe detect an overlap of topics by parties. Oh yeah, and that brings me to the end. Thank you very much for your attention. Thank you to that amazing team. And of course, thank you so much for all the amazing teachers and TAs at Le Wagon, especially Ben, Zeus, and Renan. Thank you.
So much fun, awesome stuff. Really, really impressive. Next up, we have 2 projects to go, ladies and gents. The next project, it was pitched to me by Estefania, who I don't think realized how good an idea it was at the time. The idea is to keep businesses informed on the passing of new laws that directly concern them. Laws change a lot, and it can be hard to keep up with them. Up until now, that information was scattered all over the internet, and what LexAI did is that they centralized everything on the website. Their tool is coupled with an efficient search engine and much more. Make some noise for LexAI.
Thank you, Ben. Thank you. Hello, everyone. I'm Stefania, and we want to present you LexAI. I'm quite sure that almost everyone here at the beginning of the pandemic was super lost with all the new regulations that came up every day. Maybe you will need to visit your family or your friends, and you need to check every day the regulations from your country or even from another country. And I don't know you, but I was super lost. So imagine for a company that needs to keep track of all the regulation every day, and that can affect their interests. Also, on top of that, social movements have found in social media a way to amplify its power and shape the regulatory processes. So it's very important to keep track not only about the regulations, but also the public conversation that is around it. So our solution is a tool to identify and manage regulatory risks while we keep track of public opinion. Our dashboard tracks in real time the new regulations that's coming out, and also the public dialogue around a topic and the sentiment. So I'm going to jump to the dashboard. Here's one of the pages of the dashboard, which has all the information about the regulation. For example, we can introduce a topic. Oh, this one was okay. The app already fixed the typos and also search not by the exact word, but also the related words. For example, if I search for technology, it will match with innovation or digitalization and everything. This is a graph that shows the evolution of the regulation related to the topic that we introduced. And here, just behind the graph, we have a section with the regulations. We can sort the regulation by date, select the dates, and also, if we span this list, we will have all the regulation related to technology sorted by date. For example, here you have this one that is European Economic and Social Committee, Health Technology Assessment and Compromise. The author is European Economic and Social Committee. You have the date and also the link to the real regulation, where you can find more information about it. Also, we have the public consultations that you can filter by a status. And right now it's not working, I don't know why. Sorry. I'm going to load again the web page.
No worries.
Yes, these things happen, so don't worry. In real time, it will work perfectly. Right now, it doesn't want to work, but Okay, it takes a little bit of time. Regulation is a heavy topic, you know. The dashboard needs to think. Okay, now we'll jump to the next topic, that is the social media. Okay, here we can check the sentiment analysis on Twitter about the topic and all the overall Twitter sentiment. Also, we've created a word cloud with the trending hashtags related to the topic in all over Europe. Here also we can check the industry news, always sorted by date related to the topic, and also the politicians' news. We can react directly from the dashboard to this news. And last but not least, we have an amazing map where we can filter by the type of the public. For example, we can filter what thinks politicians about technology, what they are saying, and where they are talking about this. And also, we can keep track also from here of the sentiment of the tweets. So now that you have seen everything about the dashboard, my colleague George will explain to you how it works and how we did it.
Cool, thank you, Estefania. So I'm going to talk a little bit about the behind the scenes, some of the back end that went into making the dashboard that you just saw happen. So the first thing we had to do was collect a lot of data. So we drew from a few different sources. One of the main sources, obviously, for social media was Twitter. What we did is we built a list of topics of tweets that we wanted to represent on our dashboard, say things like COVID, agriculture, fishing, those kind of things. We translated all of those topics into the various different languages in the European Union to enable us to get the most amount of tweets from all corners of Europe. Queried our Twitter API, which just contacted the Twitter's database, got those tweets for us. And of those tweets, we then used the Google Cloud Translate API to translate those all into English to allow us to process them uniformly. We also did some web scraping to get some information on the MEPs and various different press from across Europe, doing the same thing for those tweets as well from those organizations and individuals. We then went on to natural language processing. So we used a model to extract the adjectives and nouns from various different words within those tweets, and then plug those back into our database as synonyms to allow us to do the typo correction that Estefania mentioned earlier. So that allowed us to relate words to other words that were closely related, basically. We then did some sentiment analysis on those tweets to decide whether or not they were positive, neutral, or negative language about the various different topics. And then we plugged all of that information into our database. So we used the Miley Search database, which is basically just like our own private Google, very, very fast package. We can just upload data into that. And then we also added to that, without much processing, the public consultation information and the various different laws. In total, the database was about 40,000, 50,000 entries. So we needed to have a very fast solution to access all that data quickly for the front dashboard to enable it to load as fast as possible. And that's what Miley Search was there for. And then at that point, the dashboard will connect with our API, which processes the data. Obviously, the data is pulled from the database. So all of these three parts are talking to each other once you type in an input into the dashboard. Thank you. So moving forward, there were many things that we wanted to do in the 2 weeks that we just didn't get round to because it is only 2 weeks after all. So going further, we'd like to do some more natural language processing per sentiment, actually extract some of the adjectives that people are saying about various different topics, add different sources, extend to regional levels, not just the European Union level, cluster Twitter profiles based on sentiment and opinion, and also predict outcomes of consultations moving forward. So see whether or not laws will be passed based on the current conversation around those laws. So that's about it. Thank you to our team. Thank you to Estefania, who spoke earlier. And of course, thank you to Clara and Tim, who did lots of work behind the scenes. They all made this possible. And thank you as well to our lead, Georges, who was there for us for the whole 2 weeks. And thank you as well to all of our teachers over the past 9 weeks for teaching us all the knowledge that we needed to make this possible. So thank you for listening.
I can't believe that I had to push Estefania to pitch her idea and that she wasn't sure about it. Sorry, Bruno, you can't raise your hand. I'm not taking questions yet. Yeah, clapping you can. All right.
Wrong one, sorry.
No worries. Last but not least, the last group of the night, they really pushed their product to the limits of what I think can be achieved in 2 weeks. They really impressed me so much with the quality of their work, their ingenuity, and just how much they've put into this project. Audience, don't get fooled by the seamlessness of the demo. What you see is just the tip of the iceberg. The backend is a true masterpiece. I'm just going to give them the floor. Please welcome Will It Fit.
Thank you very much, Ben. Alrighty, my name is Dominic and we are almost there, so bear with me. I want you to start by picturing this scenario. You have just gotten a new home and you've been on the IKEA website and selected yourself some nice furniture. You've decided to take your car and collect it all. And then the thought has occurred to you, will it actually all fit in my car? I mean, hopefully, but how can you really be sure? Surely you don't want to end up like one of these people, right? Well, what can we do about this? Florian, Zufan, Kasia, and I have made a web app just to solve this problem. So I'll run you through it right now. We can start by selecting a language. We have about 20 websites to choose from. Then we can choose our car. I'm going to go with a Volkswagen. And then a model, let's go with a Golf GTE. Nice. We get a nice image of the car. And then we have two options. We can either upload a PDF or list article numbers. I'm going to upload a PDF. So I have the best IKEA products ever here. And simply going to ask, will it fit? So what have I just done there? I've actually gone and made a wish list on IKEA's website. So we click this heart here. I've already put it together, obviously, and you can see we've got some nice golden bowls, and we can simply right-click, print, and save this as a PDF, just like that. And now it's doing something, right? It's extracted articles from the PDF, it's gathered trunk dimensions, and now it's running an optimizer. But while this runs, let me show you what is actually happening here. So first we have the user interface, and the coolest part about this is the PDF parser, which actually goes into the PDF and takes out the article numbers and how many of each. Then we also have a car database that we built with make, model, trunk dimensions, and the image that you saw. And that we collected using web scraping, which is basically running a script to automatically collect only the parts of information that we want from a specific website. Now that we have our article numbers, we query our own IKEA database, which has dimensions of every product and article numbers. But we do this on the fly. So if the product you're looking for isn't in our database, we actually use a live web scraper to add it to our database. Both of these databases are on Google Cloud Storage, which means only our app has access to them. And then the magic happens. So then comes the optimization algorithm, which we built purposely for this from the ground up. So the first thing it does is it calculates whether technically there's enough space in the car to fit all your items. And then it checks the dimensions of each item and sees if maybe one item is far too long. If that all works, then we actually model it in 3D space. We basically simulate it and start putting packages in, rotating them, and finding ways it fits. And then we are actually running this multiple times in parallel. So at the end, you might end up with 10 solutions, and we score them and decide which one is best, and simply pass that to make a 3D plot. In this, we actually use a little bit of image recognition to find the corners of each of our packages and the car itself, and create a nice looking plot from that and pass that back to the user interface. This is all contained in what's called a Docker image, and it's on Google Cloud Run, which means anybody on the internet can access it. Let's have a look how we're going. This is still going here, so let me show you another cool feature. We'll open a new web page. Let's pick German again, and let's go with a BMW. We'll go with a Grand Coupe. Let's pick the 4-door here. Nice. And I've selected a dressing table here. And if you scroll down on any IKEA website, you'll find the article number. I'm just going to copy that and paste that in here. And let's say I want 2 of those. And I can simply ask again, will it fit? This should run nice and quickly. Oh, we have an error. So it says at least one package dimension exceeds the trunk dimensions. But a lot of cars have the ability to fold down the back seat, and we were able to get that data as well. So by simply clicking this checkbox, we can run again. Will it fit? This is looking better. We have the optimizer running now for 2 articles and 2 packages, and it's building a 3D plot, and it fits. And here we have a plot. So if you mouse over each item, you can see which item it is. In this case, it's 2 of the same. And we can even select one and turn it off. Let's see if our other one is finished yet. Yes, it is. And it does fit indeed. So here we can see all sorts of packages lined there. And another cool feature is we can show the back window. So imagine this is the space that the back window takes up. And you can also say double click a specific item to see where it is in space, or toggle off multiple items. Pretty cool. So one last thing, I would just like to say a huge thank you to my team members, our mastermind, the person who envisioned it all, and as of yesterday, brand new dad, Florian, and the other superstars in my team, Sufan and Kasia. Everyone went really above and beyond, and I can't thank you guys enough. And on behalf of, I guess, everybody, I want to say thank you to all of the teachers we've had over the last 9 weeks, all of the TAs, and especially Ben and Zuza. And last but not least, you can go to willitfit.xyz and try it out for yourself. Please let us know what you think.
Wow.
I didn't even know it was possible to do this amount of work in 2 weeks. Seriously, it's just insane how much you guys have managed to do in 10 days, not even. So this is it, believe it or not. We've gone through 9 projects. I'm super, super proud of everyone. Thanks to everyone who tuned in. And I think maybe let's give one other round of applause to all the students, 36 students of Batch 606, for all their projects, all the hard work over these 9 weeks. I'm so very proud of every one of you. Projects are amazing. It's going to take a little time, I think, to digest of all the information that you took in during those 9 weeks, but you're going to realize soon enough, like the amount of stuff that you've actually learned. Just give it a bit of time and have yourself a bit of a rest. I also want to thank the project's teaching squad, Nizar, Chris, Hai, George, Renan, Brunky, and Gian, who did a brilliant job of assisting the projects and keeping up the good vibes. Thank you again, guys, because really the projects wouldn't look like that without you. Also, I want to thank the entire teaching team, because there's many more teacher assistants and teachers that were involved in this bootcamp. I know that a lot of you are actually watching right now, so I wanted to tell you that Zuza and I are very, very thankful for your contribution to the community, and that it's always such a great pleasure to work with you. So thanks again to everyone. And finally, I'm going to thank my teammate Zuza for all the hard work, the guidance, the organization, just the fact that we're so super complementary, and that I would be so lost without you. So thank you so much for making this such a smooth bootcamp again. Thanks, Zuza.
Jump in here. I would love to jump in. A very, very big thank you for all of the audience that has tuned in, that your ability to learn and to pull through like these incredible projects, but also Ben, thanks so much for smashing this demo day. I think you've been an amazing MC. You have been really wonderful. Thanks so much for being here. Always up for love, always up to learn and learn more. This eagerness is amazing. So thanks so much. People, in a bit, I would love to see you in Birgit and Beer. It will be starting at 7 p.m. Make sure to bring your negative test and also your gute laune. And then we'll see you in a second for a nice little dance.
All right.
You're going to see more of me, people. For the ones who are in the office, please stick around. We have some goodie bags for you. So don't go just yet. And this wraps it up.
Oh.
Woo, we're done.